Hi, this is Jose Luis, and welcome to a new video on this series on Introduction to Parametric Modeling, where I'm going to teach you how to import geometry from the 3D modeling environment into the parametric modeling environment so that we can work with geometry as a source of information. But let me frame this. Why is this important in the first place? So in the example that we did on the previous video, we saw how we could create, for example, 4 fully parametric points in three-dimensional space by controlling the x, y, z of each one of those points, and then create then polylines, create NURBS curves or interpolated curves between those 4 points in a full parametric way, right? However, turns out that sometimes, for example, working with pure parametric information that has been generated numerically is not very convenient. First of all, because, well, maybe these points, the way I'm working with them right now, I can control the XYZ, but sometimes controlling the XYZ is actually not very intuitive. Sometimes we want the fluidity or the interactivity that just dragging here on the viewport, like dragging the points and moving them with the mouse, moving them up and down, it gives us a bit more flexibility and fluidity when we are modeling things. So maybe instead of working from 4 points that we have defined numerically, maybe we want to work from 4 points that we have defined in the three-dimensional environment in Rhino. Or, for example, let's say that we're working on a definition that does some parametric magic, but it needs to start from some actual data, graphical data that our client has given us, that the site has given us, that it's part of what exists in the real world. And that data may come in as CAD information, may come in as a file that you load into Rhino, and that is the data that you want to bring in into your parametric definition. Replicating all the data that you may have on a CAD file numerically here could be really tedious, especially if you're working, for example, with thousands of input points. It's just not practical. So at that point, what you want to do is you want to bring in geometry, actual geometry from the modeling environment to work as input information in your parametric modeling environment, which is what we're going to do today. So what we're going to do today is that I'm going to replace these 4 points. I'm going to completely ditch them from my definition. And what I would like to do is I would like to create 4 points that are going to exist here physically in Rhino. And when I mean physically, I mean digitally actually, but in the 3D modeling environment, right? And 3 points that I can actively manipulate and move around with the Rhino interface. And then what I'm going to do is I would like to work with this, with the XYZ and the XYZ of this as information that comes as input in Grasshopper. So the way I'm going to do that is, in the case of Grasshopper in particular, we do this by using input box parameters. What does that mean? If you go to the parameters tab, and if you go, for example, to geometry or to primitive, what you will see is all these icons that we have seen previously here when we hover over the inputs of any component. So for example, this is a point, this is an integer, this is a Boolean, and we can see that by saying this is an integer, this is a Boolean, this is a point. But if I actually use this, if I actually click on point and I drag this into the Grasshopper canvas, what I will get is this empty box, an empty component that can store or transform or manipulate point information. What does that mean? What this means is that these boxes are designed to contain collections of whichever type that component is indicating us. So in the example here, in the example of point, this box can contain this component can contain points. So what I'm going to do is I'm going to right click on this component and I'm going to set here on the options that I want to set 1 point. As I do that, Grasshopper closes temporarily and then I can select this first point here. And now you can see that the component went from yellow, which was a warning, to a full gray. And now if you click here, you can see that this component actually contains information from a reference point in Rhino. And you can see here, if we zoom in, that there's already a pre-visualization in red. If I click here, this goes green, meaning this point is contained here. And what's nice about this is that if I make any changes to the point in Rhino, those changes will broadcast, will be live linked to the box that I have here in Grasshopper. So I'm just going to drop 3 more of these, all right? And I'm going to, of course, I'm going to line them up nicely, whatever. I'm going to right click, set one point here. Now it's the second one. Now here is going to be the third one. And now here is going to be the fourth one. And now I just have 4 points that are linked to the physical points here in Rhino. And again, I say physical, I mean digital in the model here. And that I can use as 3-dimensional points for any operation in my Grasshopper definition. So for example, I'm going to plug in here the 4 points to create a polyline. I'm going to plug in here the 4 points to create a nerves curve. And I'm going to plug in here the 4 points to create a interpolated curve. Okay, awesome. How great is that? So these boxes, these empty parameter components, what they're very useful for is to load information from Rhino and to use them as input information in Grasshopper. But I just want to let you know that these parameters, all of these, in general, they're basically empty containers that can hold information either by manually loading it from Rhino or by just passing it through. So for example, you saw how in order to get these 4 points, I had to here in the polyline, in the nerves, I had to like go over one of each, one at a time, etc., etc. An easier way would have been to say, well, I loaded the 4 points independently, but then what I'm going to do is I'm going to plug all of them together into another empty box. So instead of manually loading now, what I do is I connect this one here and I have the first point. I add the second one with a shift. Now I have 2 points coming out of this component. Now I'm going to add the third one with the shift. I have 3 points, and the fourth one with the shift, and I have 4 points. This container here, this component is now storing a collection, is storing 4 points inside of it. And you can notice how the continuous single line thread wire has changed to a double wire, meaning that instead of 1 unit of data, now we have a list of data passing through this wire. And with 4 points here, now it's much easier to say, well, now I can connect this to the polyline, to the nerves curves, and to the interpolated curve, and things are a little easier to handle. So from 4 points, I have just connected to 1 point, to one list, and then that list is the list that I plug into my inputs for the geometry. That could be another way to go. A third way to go could be, well, if I know that these 4 points are always going to be the same and in that order, I can just skip all of that directly and then drop an empty box, right click and set multiple points. And then what I can do is I can say clicking in order, and the order here is very important. First one, the second one, the third one, and the fourth one. This blue line is a pre-visualization of the order. And as I right click, then the 4 points are now stored in this container, and I can plug them in here, plug them in here, plug them in here. So now I have a list, I have a component that contains a list of 4 reference points that are coming in from Rhino. And again, the beauty of this is that these 4 points still exist in Rhino, but they are linked dynamically to Grasshopper. So if I modify any of the points in Rhino, that point will be modified here on the list, and then those changes will broadcast to how I generate the curves inside of Grasshopper. Okay, so this is a really good way if you want to create like a modeling environment that allows you some hand manipulation, but at the same time it has all this parametric logic in the back end, or if you just have to work with data that somebody has given you somehow on a CAD file. All right, so let's, for example, take a look at other examples of things that we can do by bringing in data as inputs into a Grasshopper definition. For example, I have just moved away. I have turned off pre-visualization of here, and I have moved away a little bit of where I was. And I'm just going to create a bunch of points, like a few of them. All right. So for example, like several, I don't know, 10 of them. I'm just clicking right click and left click. And then I create a bunch of them. And then I can create an empty point component parameter, right click, set multiple points, and just select all of these. What you can see is due to the nature of how I have selected them, they turn out to be ordered in this sequence inside of Grasshopper. But now I have here a list of 16 different points. Now with this, I can do whatever I want. I can, for example, again, I can create a polyline, for example, between them, and then it creates that object there. I can create a NURBS curve from all of these points, all right? And then it creates this kind of fun squiggly line between them. That's kind of cool, right? I like this, actually. Or I can create an interpolated curve. This is a very common operation because very often we want to go through the points. So I'm going to create an interpolated curve. I'm going to turn off the other one and this other one. And you can see we also get a fun kind of interpolated curve. And again, if I modify any of the input parameters, any of the input points, everything adapts accordingly. All right. Or something that I can also do is I can use these points as centers for primitive surfaces. So for example, if I go to surface, primitives, and I go to sphere, and I place a sphere here, if I plug the point into the center of the sphere, you can see that each one of the spheres now is centered around each one of the points. Because the sphere, when it's given a list of data, it just applies the same operation to all the elements on that list. Further down in this list of tutorials, I will teach you how Grasshopper works with data and how can we manipulate streams of data. So that's another point. Or for example, if instead of points, we are tired of points and we want to do something different, something that we can do as well is we can use curves as inputs. So for example, let me say that I'm going to create this curve right here. And then I'm going to move over here and I'm going to double click and type on curve, which is, because of the hexagon icon, this is an empty parameter component that can contain curves. If I right click here and I set one curve and I click it, now this curve has been referenced in my Grasshopper definition. I have a referenced planar curve. And for example, I can create another one here, and which I can, for example, move a little bit in the Z direction. I'm going to bring that one in as well. So for example, curve, right click, set one curve, and I'm going to bring it in. So now that I have these two curves, things that I can do is, for example, I can generate a surface that is a loft between these two curves. So for example, I can go to surfaces, freeform, and I can find a loft component. This creates a lofted surface through a set of series components, of curve components. So for example, now I can plug my first one here, and then if I plug the second one with the shift so that it adds in both, you can see that I have a surface that is lofted between the two curves. And if I now change any of the curves, so for example, if I move it, the surface adapts. Or if I change any of the control points, so for example, I drag that around, the surface adapts to those changes. You see? And as soon as I get, by playing around with the two curves, as soon as I get the exact right surface that I like with the smooth surface, it's a whatever, I can just right click, bake the object, and then I will have a copy, I will have a static copy of that surface that I can now send to other programs for rendering, for 3D printing or whatever. And remember, as per our previous videos, remember that if I still choose the curve and I move it around, the curve has lost the relation, the surface has lost the relation, the one in Grasshopper has lost the relation to the one in Rhino, because the Rhino one is just an imprint, it's like a footprint, it's like a stamp of when that surface, when we baked it. Okay, wonderful. So this is bringing data into Grasshopper as an input. We will do that a lot in the examples that we're going to see very soon. Okay, so actually I think at this point right now we know enough so that we can work on a few examples just to practice things out. Okay, so see you on the next video where we're going to do some practice exercises to get stronger on everything that we have learned so far. Okay, and remember, if you like what you saw, please consider subscribing, liking this video, turning on notifications, and all of that stuff. Thanks a lot. See you in the next video.